On screen joining me is Bob Kruse, Senior VP of Product Engineering at Faraday Future. Quick little intro for Bob before we get stuck into his presentation. Robert Bob Kruse Jr. joined Faraday Future as Senior Vice President, Product Execution. Bob is responsible for leading the entire product development, engineering and manufacturing team at FF, an automotive industry veteran with over 30 years of experience at General Motors and other consulting and startup companies. Bob recently served as CTO at both Karma and Kruse to lead all product development and advanced technology. At Karma, Kruse led the engineering team that launched Karma's award-winning Revero luxury electric vehicle in 2017, and at the company's newly announced 2020 Revero GT. Bob's career is largely shaped by 31 years at General Motors. There he led the team that executed the Chevrolet Volt and the development of the largest battery testing, facility in North America. As a senior General Motors executive, Bob developed vast experience with lean engineering and manufacturing techniques, leading teams that engineered some of the most successful vehicles in the company's history. Kruse was also the co-founder and co-director of GM University of Michigan Advanced Battery Coalition for Drivetrains, a partnership created to accelerate the design and testing of advanced batteries for electric vehicles. Kruse earned a MS in management from the Massachusetts Institute of Technology as a Sloan Fellow, a BS in electrical engineering from the Missouri University of Science and Technology, and he also serves on its engineering advisory board. Incredibly impressive credentials, so we are saving the best for last for today. Later, Bob will be joined by two of his colleagues as well, who will step in and answer any questions that might not fall into Bob's remit. What I'd like to do, of course, is I would like to hand things over to Bob for the next 30 to 35 minutes, and he will take you through his presentation. Over to you, Bob.
Great. Elishba, thanks very much for that kind introduction. I am joined by two colleagues, John Schilling from our communications department and Sham Sundar from our autonomous and artificial intelligence organization, and they will help with any of the questions and answers at the end. So thanks everybody for your participation and attention. We're very pleased to be able to join the session. We've got a lot going on right now, and I'm sure you've read about much of what's going on in the press recently. I'll be discussing Faraday Future's next generation modular electric vehicle platform and some of the associated technology. So first, a little bit of history. We were founded in 2014, and we got from concept and ideas to our first prototypes in about 2 years. As you know, the company got into some financial restraints and stalled, and our new CEO, Dr. Karsten Breitfeld, was hired about 18 months ago to turn the company around, stabilize it, and bring the product to production. Karsten recruited me to Faraday just about 16 months ago or so. I joined Faraday because I'm a big electric vehicle proponent. I'm a big technology guy, and when I look at the opportunities of where the internet meets electric vehicles, you know, I found what I was looking in for my next challenge here at Faraday in launching what we call the FF91, which I'll tell you a little bit about in a few minutes. So Karsten's turned the company around, stabilized it, and you know, we now have rebuilt the team. We've got a leadership team with top executives from all over the industry. And we're excited about the future. So we call it our variable platform architecture. It's flexible and scalable. Our electric propulsion units are also modular and can be reused across vehicles, and we'll talk a little bit about this later. We have industry-leading power density. Our battery systems are also modular and can be reused across our vehicles. Our battery is made up of cells into modules, into strings. Each string is an individual battery pack as itself and becomes very modular. And then our UX UI system provides a user ecosystem that will be segment defining with enhanced connectivity and the benefits of electric propulsion with maximum torque at 0 RPM are also significant. So let's talk a little bit about the product first. We're a technology and product-driven company, and we're very proud of the technology we've created, especially for the FF91, which is a class-defining or redefining product, okay, that has a higher performance luxury electric car offering with a great user experience. We have about 380 miles of EPA range, 1,050 horsepower, 0 to 60 miles per hour in 2.4 seconds. That's like wicked fast. That's rocket ship fast. Okay. We have very fast charging, true mobile connectivity with a user experience that's unrivaled in the industry. And we really call ourselves and call our product a smart device on wheels. We've been driving pre-production vehicles over the last 6 months, many on an almost day-to-day basis. I got to tell you, you're treated like a rock star or a movie star everywhere you go in the vehicle. It commands lots and lots of attention here in Southern California. And you get addicted to it right away. You know, that connection between your right foot and instant acceleration of 1,050 horsepower for a car guy is truly awesome. And then when you couple that with the connectivity and the user experience, it's really an experience that's second to none. So our platform architecture so we've built upon our success on this variable platform architecture, our industry-leading propulsion technology, our internet, autonomous, and intelligent technology, and our hybrid manufacturing strategy. To start, our variable platform architecture is a flexible skateboard which can be used for a wide variety of different vehicles that is a common base across all of our product offerings. It's easy to scale in wheelbase, battery size, motor power without major investments, and these adaptations can be very fast because there's almost no new validation required to get these different configurations. And it makes sure that all of our derivatives can be easily integrated into our manufacturing systems. And the EVPA is absolutely unique in the industry and gives us a competitive advantage to speed to market and cost. Next, we have a technology portfolio that has two main parts. One is industry-leading electric propulsion technology, and the other is connectivity, software, and artificial intelligence. The industry's leading propulsion technology includes a unique battery technology with liquid cell cooling. We flood our battery cells in a non-conductive dielectric fluid, very, very thermally efficient. We have an inverter with parallel IGBT processing that's patented, and it is one of the more compact inverters in the industry with a very high efficiency factor of over 98%. And a drive unit that's the most compact in the industry, highly efficient and modular. Our connectivity software and AI offering includes a high-performance computing platform, an operating system which allows multiple users to log in through facial recognition, is Android-based and open, and we have a complete ecosystem of applications and a cloud managing the whole user data based on machine learning that adapts to users' preferences. Faraday is uniquely focused on not only the driver, but all passenger positions. All seats in a Faraday are a good seat with lots of connectivity and lots of performance. Now, our aluminum structure includes front and rear modules supporting either 1 or 2 electric propulsion units. The battery pack is expandable for wheelbase and range. We have a wide track width. We're very fast to market with our derivatives, and our derivatives are focused only on new top hats and new interiors and exteriors. Now let's talk a bit about technology, which is the core of our competitiveness. Our technology portfolio has two main parts: industry-leading propulsion technology, connectivity, software, and AI. We have the unique battery technology with liquid cell cooling, which leads to the highest energy density, very fast charging, and the highest level of safety in the industry. We use industry standard 21700 cells. Our strategy is cell agnostic. We can use anybody's 21700 cell. The system is flexible, and we flood those cells in a non-conductive dielectric fluid that allows us to position those cells closer together than anybody else. And we hold the patent on this approach. We also hold the patent on laser welding our cells directly to our current collectors, so we have half the welds per cell that others do where they use wire bonding. Okay, what that does is that reduces the amount of resistance or I²R losses, which generate heat. We also cool our welds. They're flooded in that non-conductive dielectric fluid. And as a result, this gives us the highest gravimetric energy density at the pack level on the planet. And this was externally validated by Roland Berger. Our inverter is the most compact one in the industry and is directly attached to our drive unit, which makes the whole system more compact, save weight, cost. There's no cables between the motor and the inverter, and it has a very high efficiency factor of over 98%. The drive unit is a very compact one. It's highly efficient and modular. Each unit is 350 horsepower. We can couple those for 350, 700, or 1,050 horsepower as configured in the FF91. This creates an economy of scale within our own product portfolio. And our drive units also have the highest gravimetric power density as a result. And though that power density performance was also externally validated by Roland Berger. So our variable platform architecture is a flexible skateboard which can be used for a wide variety of different vehicles. It's a common base across our product offerings. Our pack is divided into strings, each with a positive and negative contactor. Each one of the orange boxes on the picture is a string. It's essentially a small battery pack onto itself. So it's very easy to scale in wheelbase, battery size, and electric motor power without major investments or long validation times. These adaptations are very fast, no new validation for all the different combinations, and it makes sure that all of our derivatives can be easily integrated into our production systems. This VPA is absolutely unique in the industry and gives us a competitive advantage to speed to market and cost. You can see in the picture, the battery pack is modular. The orange boxes are strings. The front and rear modules are also modular with either a 1 or 2 motor configuration. In the FF91, we use 6 strings, about 130 kilowatt hours, and 3 motors for the 1,050 horsepower of performance. So as I mentioned, we drive this car on and off on an almost daily basis over the last 6 months or so. It's a very interesting experience, attracting a lot of attention, wicked fun to drive and use. You know, that 380 miles of EPA range, we get that, okay? And you may have the experience from EPA range of today's cars, which are never met. Under real operating conditions, the FF91 delivers what it's promised, and we've proven this. When I first joined Faraday, Karsten and I drove one of our vehicles from LA to Vegas, which is about 270 miles on a single battery charge, and we arrived with about 110 miles of range left. We did make one stop for a biology break in Baker along the way. And we also, there was a Tesla fast charge station in Baker, so we stopped and took a few pictures and, laughed at the Teslas that had to stop and charge while we just continued on our way. We also, a couple years ago, raced up Pikes Peak. As we raced up Pikes Peak, we did set a record that particular day. Tesla was racing that same day. Their battery pack got overheated, and we have pictures of their engineers stuffing bags of ice under their pack to cool. Because of our flooded cell proprietary patented technology, our pack did not get heated in a very, very challenging race up Pikes Peak. So in every category which is relevant for electric cars, the FF91 is the best or among the leaders. The most horsepower, fastest 0 to 60, best range, and charging time. And to share an independent view, this is a comparison study that was based on data provided by our consultancy firm, Roland Berger, and it shows the FF91 is market leading in gravimetric battery energy density and gravimetric EV propulsion power density. Both of these factors help to reduce weight, improve performance, and increase range of our vehicles. In the last couple of years, we've had discussions with several aspiring EV makers, traditional OEMs, as well as companies in the aerospace and marine domains, and even with some off-road equipment manufacturer. We've seen a lot of potential for adopting our battery architecture and electric propulsion technology to other applications. I expect we'll be announcing some of these engagements in the future, but we're open to conversations with other potential partners that might be interested in any of our technology. Sorry, I hit the wrong button. So before I close this presentation, I'd like to show you some of the impressions of the interior experience of the FF91. The pictures showing here are not computer animation, but are photos of the real product, which you can experience on the road in and about Los Angeles, as we speak. What you see is a new benchmark in user experience for the driver and the passenger, with interior refinement and a digital experience other companies have not even imagined. If you enter the rear, you'll find the largest legroom with 49 inches. It's an executive first-class experience comparable to what you might find on a great airline. People who've been in the car compared to experience like Rolls-Royce or Bentley with just even more legroom. We have a 27-inch rear screen in the back to help enhance that user experience. The rear seats can be reclined to 60 degrees, NASA-inspired zero-gravity seats. There's a spa mode, which gives you the ultimate experience in comfort and relaxation. So if you detail some of the experiences you might see in this new benchmark for drivers and passengers for interior refinement, the digital experience other companies haven't even imagined yet, the functionality shown here is installed in our car, is operational. If you walk through the driver experience first, as you approach the car, it identifies you through facial recognition, some welcome light effects on the rockers and the front of the vehicle, and then automatically opens the doors for you. So it's truly a touchless entry. So then it will identify you by face recognition in the vehicle, log you into your FF Cloud, set all your preferences without you touching anything, and then you'll tell the car where to go with a voice control system and navigation that will select the best route. And when you arrive at your destination, the car can park itself under most normal conditions. And so our voice experience, it's a voice-first user experience that's capable of interpreting multiple complex phrases like, find me an Italian restaurant with outdoor seating that's 5-star or greater. And it will interpret all of those complex commands and sort exactly what you're looking for. while the front seat is differentiated from the competition, the rear seat experience is unparalleled. Here's your experience. If you imagine your kids are at home watching a Netflix movie, and after some time you decide to go out to dinner, so you shut off your display in the living room, you leave your home, enter the car, your kids enter the rear seat, find a very spacious environment, and while you ask the car to find that nice restaurant I just described with outdoor seating, your children can continue to watch their Netflix movie at the exact spot in the exact location where they stopped watching it at home. That's possible because not just the driver, but every passenger is logged into the FF cloud through facial recognition and have complete access to their digital ecosystem. Again, that big 27-inch rear display, which is very unique in the industry. Nobody else has it. And just to give you an idea what leading technology for connectivity means, there's a gateway module with 3 modems to ensure continuous network coverage at all times. So that's an example for a user experience, okay, that's second to none. And you can do much more. The operating system is Android-based, so users can install their own apps, and it's a very cool feature, our individual sound zones for the passengers that can individualize their audio experience. And you see the FF91 is truly a smart device on wheels. So that concludes my remarks. And so now Sham Sunder from our autonomous organization and John Schilling will join me, and John will be moderating the Q&A for the rest of the session. So thank you very much. We would entertain your questions.
Yes, thanks, Bob. This is John Schilling from FF's Communications Department. Happy to facilitate questions if anybody has any. I see one that just popped up. So I will ask Bob. Can you hear me, Bob?
Yes, I can.
All right. The question is, what is the battery voltage, and is it the same for different car models?
Yeah, so we're nominally a 400-volt system. Each one of those strings that I talked about is currently a 400-volt string. Each string you can think of as a standalone battery pack. And to get, more battery capacity or more range, we just add strings without having to redesign a whole pack. We do have, sites on an 800-volt system and can easily modify the modules inside each string to make each string an 800-volt system. That's not today's problem. We're launching at 400 volts and 130 kilowatt hours.
Great. Thanks, Bob. Are there any other questions from anybody in the audience? This is the time to ask. Okay. Oh. Okay. Here's another question. If the VPA platform is to be used on future vehicles, how do you foresee the protection of future advances in chassis technology and ADAS technology?
Well, sure. Well, it is the basis for future platforms. But as we upgrade, whether, as I just talked about, either upgrading to an 800-volt system or improving the efficiency of our motors and inverters, it's modular. We can do that across all the platforms and reuse it. The user experience and the ecosystem has very powerful onboard capability with over-the-air updates, which will bring both performance improvements as well as feature function additions, after the original point of sale. And I'll invite Sham to elaborate on that.
Yes, so the ADAS system, the autonomous driving system, to be more specific, is independent of the VPA chassis. So definitely that can evolve independently. And so can our infotainment and compute system. So we really take more of a platform approach, a reusable platform approach, similar to how we do it in software. So effectively, each of these individual platforms can evolve independent of each other.
Thanks, Shyam. John, next question.
Thanks, guys. When will the vehicle be available in Europe?
We haven't announced a release date in Europe. We're launching here in the United States about 12 months after our SPAC merger is complete, which is targeted for the merger is targeted for next month, US for sale shortly thereafter, or a year thereafter. And then a few months behind that, we'll be launching in China. And then a few months behind that, we'll be moving to Europe. So we have not announced specific timing for Europe, but it is on the radar that we will be able to have the FF91 in North America, Asia, and Europe.
Great, thanks, Bob. Next question, is the body aluminum or composite material?
The body structure and the body itself is mostly aluminum. Of course, there's glass and other elements, but it's largely an all aluminum vehicle.
Okay. Thank you. Next question is, what is the recharge time to 80% for the vehicle?
The recharge time to 80% is in the 20 to 25 minute range. Of course, it depends upon the capacity of your DC fast charging. So from a charging standpoint, we do have an onboard charger that's capable of supporting industry standard level 1 and level 2 charging. And then it is also, level 3 DC fast charging compliant. And that will depend, we have a very large pipeline into the vehicle, and depending upon the capacity of the DC fast charging unit, will govern that specifically, but it's in the order of 20 to 25 minutes.
Great, thanks, Bob. Next question is, does the coolant flooded thermal management system affect the weight at all of the vehicle?
Well, of course it does, okay, but what you have to recognize is the energy density. So every electric vehicle, has some type of coolant system. Some companies, snake a ribbon of coolant, that serpentines through the pack, tangentially touching every cylindrical cell, if that's what they use. So what we're able to do is we're able to place those 21700 cells closer together, because it's like if on a hot day, if you're hot and you approach a swimming pool, if you put your foot in the pool and just cool the battery from the cell on a plate or on the side, it takes a long time to cool your body. But if you jump in the pool, you're immersed in cool water and you rapidly cool down your body. That same thing happens for a cell. So we have our thermal mass, because of the flooded cell technology, lets us put those cells together. So we're cell agnostic. We're currently partnered with LG. So as the cells get greater energy density, that's like a tide that raises all ships. The Faraday patented technology lets us put those cells together. So as cells get better, we'll all get better. And our pack energy density, which is what I think is the metric that really matters, is gravimetric energy density at the pack level. You saw on the Roland Berger chart, we're superior, and as cells get greater and greater energy density, we'll be able to manage the thermal efficiency very good with our patented flooded cell technology. And again, it's important to understand that when you weld connections to a cell, that's a point of resistance that creates heat. And by also cooling our welds, we also manage the thermal efficiency of a point of heat generation inside the pack.
Great. Well, next question is somewhat related. With the immersion cooling technology available, would leaking or corrosion be an issue at all?
Of course, you have to manage. We have a design that's very robust long term to leak, so we can maintain the dielectric fluid it's serviceable, but it's intended to be for the life of the vehicle, and corrosion is not an issue.
Okay. Changing direction a little bit, who do we see as our closest competition? Who do you see as your closest competition?
Well, that's the really great point about the Faraday business strategy. If you look at, where we're launching the FF91 in the ultra luxury segment, whether it be Rolls-Royce or Bentley, there really isn't, electric vehicle competition there. That's how we've chosen to build our brand, creating a vehicle that almost everybody wants and nobody can afford. And then as we go downscale and as we have subsequent vehicles, the FF81 comes behind it. You can think of that as a Model X or Model S competitor. And then we have the 7.1 behind it, the FF7.1, which is a Model 3 competitor. So we'll eventually cover wider segments of the market. But as we launch the FF91, there really is no competition.
Great. Our next question, are you able to offer a battery update?
Actually, John, let me come back. And in addition to that,
okay.
when you couple that with the connectivity and the user experience, it's really an unrivaled total vehicle experience. And, we have coined the term the third internet living space. So if the first two are your office and home, the FF91 will define that third internet living space in your personal transportation. So apologize. Go ahead, ask the next question.
Good. Thanks for that clarification. Are you able to offer a battery update at a later date or in the future of the vehicle?
We consider the vehicle to be, or the battery to be, life of the vehicle. So I don't anticipate we will be updating the battery. We will be having batteries of different sizes for different models. But the FF91 is going to be a 6-string vehicle, through its life.
Great. Another question related to the cooling fluid. Is the cooling fluid used an industry standard coolant or specific thermal fluid, which will have high thermal connectivity?
It does have very high thermal connectivity. The approach is patented. We have, I think, over 880 patents filed, 500 and some granted. Several of those are targeted at the thermal system of the battery technology. And so we're very proud of it. It's what enables that industry-leading gravimetric energy density at the pack level.
Great, thank you. Maybe one more question. What was the reason for going for cylindrical cells compared to pouch or prismatic cells?
Cylindrical cells are an industry standard. They're readily available. There's many manufacturers that make them. And so, there's much debate, are cylindrical cells better or pouch cells or prismatic cells? I don't know what the right answer is. At GM, as you know, for the first generation Volt, we used pouch cells. I've done vehicles that have used pouch cells, prismatic cells, cylindrical cells. I don't know that one is better than the rest. It's how you integrate those cells into a system. And the system that's enabled by that those Faraday patents and technology is what enables that industry-leading gravimetric energy density. And we use 21700 cells, which many other people use as well.
Great, thank you, Bob. Maybe one more question, and then if we didn't get to everybody's questions, I would encourage people to send me a note. I can get you all my contact information. We could follow up at a later time with any unanswered questions. But maybe, Bob, if you could talk a little bit about the price of the vehicle or price range. I know, obviously we haven't announced the official price of the car, but how the pricing structure is going to work and how that plays into FF81 and FF71 that will follow future.
Yeah, I will tell you the vehicle will be competitive. I'm not going to announce price at this particular point in time. I'll leave that to I'm the engineer, I'm the technology guy. I'll leave that to the marketing guys on a different day in a different webinar. I can tell you we have very competitive costs that will enable a very competitive price. But you also have to, recognize the content and the performance that you get for that price. So stay tuned for future announcements.
Yeah. Great. Thank you. Okay. Well, I think we'll wrap it up. And again, like I said, if we didn't get to your question, I think Bob did a great job answering a lot of questions. I think we can talk to the organizers to have you guys send me any notes, and I can follow up with Bob at a later time. So with that, I think we'll conclude. And Elishba, I don't know if you want to hop back on and say a few words.
Yeah, John, thanks for moderating. Elishba, I think the presentation you can make available, as people would like it.
Mm-hmm. All righty. Well, I'd like to thank all three of you, Bob, John, and Shyam, for, of course, stepping in and, of course, handling the Q&A there. What I would like to do, guys, is I would like to wrap things up for today. As previously mentioned, the General Motors speaker is unable to join us today, which means we're one presentation short. If I hear from him this evening, we will work him into the schedule for tomorrow. But for now, this is the close of day one. I would like to thank everybody who joined us today, not only the speakers, but also the attendees. I know it's not the same experience joining digital meetings, but we're trying to do the best we can to keep everyone engaged. As I mentioned previously, all the content, the recordings, as well as PDF copies of the presentations are made available to anyone that would like them. With regards to the recordings, all you need to do is join the same link as soon as the meeting's over, and you will be able to watch everything on demand, including the Q&A for all three speakers. For the PDF copies of presentations, all you need to do is drop me an email. It's my first name dot last name at ikpc.co.uk, and I will be happy to send them to you later this evening. Once again, I'd like to, of course, thank everyone for joining us. We will be back tomorrow, same time, 2 p.m. UK, 3 p.m. Central Eastern Time, and 9 o'clock Eastern Standard Time, with 3 presentations and a panel to close. So I would, of course, be happy, and of course the automotive team would be more than grateful if you can join us then as well. For now, and on behalf of the rest of my team, I'd like to thank everyone for being part of day one of the meeting, and of course wish all of you a great rest of your day, afternoon and evening, wherever you're located. Thanks very much, gents.